Hopefully the graphics explain what's going on here, but we're going to look at the idea of designing within graphic communications. Should we fake design and make things up? I'm suggesting that maybe a different approach might be to look at real products. Analyze existing well-designed products that we can sketch, we can model, we can detail, and with all our unique skill set within this subject, then look at how we might want to improve them, modify them, or alter them in some way. Why? Well, existing well-designed products that can be measured, we can dismantle them, measure them again, study them, see how they fit together, the limits and tolerances, the materials and the possible methods of manufacture. So getting real, let's start with some simple and build to complex forms. Always real. Kids' toys are a great starting point. So design must be safe, it must be robust, well made, and even the simplest toys have the benefited from real design. So let's learn from this. These are sketches of a toy tractor. It's speeded up 8 times real speed, and it shows the elevation and end elevation of this little toy based on a few cylindrical forms. Now the students who would be given this would be given, in the cases we've used it in the past, a manual orthographic assembly. They don't actually see the product, they won't actually see the product at all. They're going to work just from the information given in the form of this type of orthographic view. A little bit more detailed, a little bit more structured. This is the sketch version for the purposes of this demonstration. So with information given there, they've then got to analyse the 2 or 3 drawings and work out what the forms involved are and how they might be constructed. In this case, the sketch at the side would be something students would have to do from the information given purely in 2D. Some of the forms are more complex than others, things like the wheels, fairly straightforward cylindrical form with a drilled hole in it. The chimney is another dowel type form. There's various dowels for chimney posts or for axles. And we've got this chassis or engine part, which is a square section cut to an L with 2 holes in it. Now we need to put some dimensions on this, and the students at this stage would be introduced to the real product and shown the actual physical toy. That allows them to look at a little bit more detail rather than just analysing an orthographic view. And from that, using measuring equipment like calipers and rulers, etc., they would take dimensions, some of which would be recorded in 2D, some of which would be recorded in 3D. In this example, there's probably more 3D than the students would do first thing, but the idea of the 3D drawing here is to say, look, these are basic forms. A cylinder of height and diameter can be recorded with little notes alongside, whereas something as complex as the cab, for any preliminary sketch, and it's an analytical type of sketch, remember, would require a little bit more detail. So we're just jotting down here space for the dimensions. No numbers will appear in this case, as I've not got them with me at the moment. So we can dimension 2D and 3D. We put additional notes alongside, for example, hole sizes, whether it's drilled or a through hole or whatever. We may need, as I said, a more detailed orthographic view, and I think the cab part that's shown here at the top right is definitely right for a more detailed elevation, end elevation type of drawing with space to put the more detailed dimensions on that. We don't normally dimension 3-dimensional complex things, or indeed we don't dimension assemblies that much because there's too much happening. So dimensioning parts, 2D or 3D, and the students would then have a chance to work out how that product goes together, the materials involved, how things fit together, the relevant sizes of fitting and holes and poles. Then from the information they've been given, move on to produce CAD planning sheet, an idea of how they're going to use, in this case it would be Autodesk Inventor, and sketch, extrude, add sketch planes, remove parts, etc. From that they'll produce details onto parts, assemblies, sectional views, exploded views, and maybe even scenes of different renders. That all comes from the preliminary work done earlier on. But now what can we do in terms of variations on that product? We could look at it, we could check any changes, and we might consider how we might modify this design. We know it works, it exists, we've modelled it, and we'll have some good graphics to go with that. But now let's see if we can modify it in some way, possibly just to change the product slightly for appearance or for a market group or for safety, although the product itself is robust in terms of safety. Or we might add a function, for example, we might allow the front wheels to steer in some way. So looking at parts, and the chimney is a classic example, we'll come back to how would we modify, could we modify the chimney? 2D sketches give us some variations very quickly. 3D sketches would give us an idea what the form might look like. And obviously safety is very important in that area, something that's sticking out a product like this. So the cab can be done, the radius corners on the body, the wheels, there's an infinite number of things we can do there. And that's the area I'm suggesting, or we would suggest, that design could come into the product side of things, but not until the students fully understand the product.